Welcome to Daily Papers, the podcast where we break down cutting-edge research into a conversation you can actually follow. Today, we're talking about a problem that's quietly exploding in the tech world, AI that helps you code.
Right. These AI coding assistants are everywhere now. They're like a super smart partner who can write code in seconds. Developers love them because they speed everything up, but there's a catch. Imagine hiring a brilliant builder who works at lightning speed but forgets to install locks on about half the doors and windows.
That's not a great builder, and that's pretty much the core issue this paper tackles. A recent report found that these AI assistants produce vulnerable code in nearly 45% of security-related situations.
And when we say vulnerable code, we mean code that has security flaws that hackers can exploit. Think of it like a digital unlocked window. This isn't just a small bug here and there. We're talking about serious issues that could lead to data breaches, stolen passwords, and all sorts of chaos.
So why is this happening? Why are these incredibly smart AIs so bad at security? Well, it's the classic garbage in, garbage out problem. These AI models learn by reading billions of lines of code from the open internet, places like public code repositories and old forum posts.
Exactly, and a lot of that code is not great. It might be from a 10-year-old tutorial, or it's just a quick example never meant to be used in a real live application. The AI learns what code looks like, but it doesn't learn what secure code requires. It's like learning to cook by only reading recipes from 1950. You might get the basics, but you're missing all the modern knowledge about food safety.
So the obvious solution is to teach the AI better. We need to give it a better textbook, a better training dataset. And people have tried. But this paper, titled SecureCode v2.0, a production-grade dataset for training security-aware code generation models, argues that the existing textbooks are deeply flawed.
They point out a few huge problems. First, existing datasets are often full of synthetic examples. They're like made-up problems you'd find in a high school math book. They teach the theory, but they don't reflect how real vulnerabilities actually show up in the real messy world. The paper found that in one popular dataset, fewer than 1 in 5 examples were tied to a real documented security incident.
It's like trying to train a firefighter using only cartoons of fires. They might learn that fire is hot, but they won't be prepared for a real chemical plant explosion. To be effective, the training has to be based on reality. This paper calls that incident grounding.
The second big problem is the format. Most datasets just show you a snippet of bad code and a snippet of good code, but that's not how developers work. We don't just ask an AI for one perfect piece of code and walk away. We have a conversation.
Right. You ask for something, you get a response, then you ask a follow-up, like, okay, that's great, but how does this scale up? What are the performance trade-offs? Security needs to be part of that entire back and forth.
And that brings us to the third flaw: no operational guidance. The old datasets show you the secure lock, but they don't tell you how to install a security camera, an alarm system, or what to do if someone smashes the window anyway. Security isn't just about writing perfect code, it's about having layers of defense.
So this is where SecureCode 2.0 comes in. The authors decided to build a completely new textbook for these AIs, designed from the ground up to solve these problems.
And the first principle is that every single one of its 1,215 examples is grounded in a real-world incident. Each example is linked to a CVE. That stands for Common Vulnerabilities and Exposures, which is basically a unique ID for a known security flaw. They studied actual data breaches like the ones at Equifax and Capital One and built their examples based on what really happened.
So instead of learning from cartoon fires, the AI is learning from the case files of real-world arsons. That already sounds way more effective. But the most interesting part, I think, is how they structured it.
It's brilliant. They threw out the old bad code, good code format. Instead, every example in SecureCode 2.0 is a 4-turn conversation designed to mimic how a developer really interacts with an AI.
Let's walk through it. Turn 1 is the developer asking for something pretty normal, like, hey AI, can you help me build a user login system? Notice they don't even mention security.
Then comes turn 2. The the AI's response, and this is the magic. The AI provides two versions of the code. It first says, here's a common way to do it, but be warned, this way is vulnerable to this specific attack. Then it says, here is the secure way to do it, and here is exactly why it's better. This is called contrastive learning, learning by comparing a bad example directly with a good one.
Okay, so the developer gets what they asked for, plus a built-in security lesson. Then comes turn 3. The developer asks a follow-up question, pushing for more realism. Something like, okay, great, but how does this scale up? What are the performance trade-offs?
And that leads to turn 4, where the AI provides that defense in-depth advice we talked about. It gives guidance on operational security. It might say, to support this at scale, you should also implement logging to track failed login attempts, set up monitoring to alert you of suspicious activity, and here are some notes on how to respond if you think you're under attack.
It's not just giving you the code, it's acting like a senior security engineer mentoring you through the entire process. It's teaching good security habits, not just giving you a snippet of code.
And they've done this across 11 different programming languages, covering the most common types of vulnerabilities you see online, ranked by security experts in something called the OWASP Top 10. They even created an automated system to quality check every single example to make sure it met their high standards.
So what's the big picture here? The goal is that companies and researchers can take this high-quality dataset and use it to fine-tune their AI models. The next generation of coding assistants could have this security awareness baked in from the start.
It shifts security from an afterthought to a core part of the development process. Instead of writing code and then having a security team find flaws later, which is slow and expensive, the AI helps you write secure code from line 1.
So if today's AI coding assistants are like a brilliant but careless builder, this paper provides the blueprint for training them to be master architects who are also experts in security systems. It's about giving our powerful new tools the wisdom they need to be used safely.
And by making the whole dataset and their validation tools open source, they're inviting the whole community to build on their work, a truly foundational paper for a more secure future.